antenna experiment. This is antenna tripod. You can't shoot short films in this, but you can place antenna on that. You need to set this at 0. So you need to loosen it and then set this needle to 0 and then tighten this. This part you need to tighten. This is for horizontal rotation. And then this one is to lift this. But we are not using vertical thing in this experiment. You are only using this to rotate and this to move this part up and down. You need to place this bubble at the center and then tighten this and then place it in such a way that this looks horizontal. This is not correct, this is correct. Now this is proper. Use this as a receiver because this thing can't rotate. This disc is not proper. This is dipole antenna, this is Yagi-Uda antenna, this is the detector. There you find 3 dB attenuator. It's written on that 3 dB. Mark is done. This is 6 dB attenuator. This is 3 dB attenuator. The marking is done, but you don't see any ink on that. Okay. Manual. Okay, there are 2 antennas. This is the transmitter, this is the receiver. From the microwave source, that is the blue box here. From the microwave source, you need to connect 3 dB attenuator. From there, 3 dB attenuator. You connected a 3 dB attenuator over there, and then from that, the cable to transmitter antenna. Direct hand the cable. Direct. And then from the receiver, you need to connect a detector. It's written in and out. That's in, this is out. Input. Output is given to VSWR. From the receiver, input, and then from output of the detector to active filter. From the detector, you need to give it to active filter. Input of the active filters. This cable goes to the input of active filter, and from the output of active filter, you need to give it to VSWR meter. Use the black cable. DVDs.
Complete circle. See, first inner circle was complete.
What's the gap between these two antennas?
50 centimeter.
50 centimeters. Okay.
It should be aligned.
Okay, we need to connect the dipole antennas first. Keep it horizontal like this to measure measure the gain for E plane, and turn this vertically and turn that vertically to measure gain for H plane. Yeah. For the VSWR meter, these two should be at maximum, and then this should be at normal. And this you need to vary according to whatever input you get. And this should be towards the crystal frequency. Yeah, XTA or something. In the active filter, even this should be at maximum. In this you need to vary the frequency. In this you need to vary the frequency, set it to 2.3 gigahertz and then vary by 0.1 gigahertz.
You get a maximum radiation of 2.3.
Okay, from 2 to 3 gigahertz you need to vary. Okay, in the same antennas experiment, you need to vary the frequency from 2 to 3 gigahertz while keeping this in horizontal, that is E plane. Yeah, this is E plane. And then set the VSWR here, the second line, dB, while varying the frequency in electronic source. Here, whenever you get maximum, you set the frequency over there, keep it constant, and then start rotating this.
2.3.
Yeah, in maximum you might get it through 2.3. While keeping this as constant, then you need to rotate the transmitter and check for E plane, and then take values for H plane. Okay, in this step, there's a small connection when you connect directly from the source to VSWR to 3 dB attenuator and detector. When you do the antennas experiment, you get the maximum value, the resonance frequency. When you vary from 2 to 3 gigahertz, you get the maximum value of certain frequency. While keeping that frequency in the source, you need to connect directly here. So you will get PT here. This is done for PT. Correct? These antennas should be minimum 50 centimeters, 50 centimeter distance apart. But while setting up, when you are connecting the source to the transmitter and receiver to VSWR meter, you need to set the frequency over there at 2.5 or 2.3 or so, and then check for 25 dB while moving this antenna towards you. Make sure you have 50 centimeters distance minimum. If you get 25 dB over there, then keep the frequency as it is, and then proceed.